could be projected on a 3D space from a higher dimensional, and you're crossing out different, like the platonic solids.
Go ahead and look up what Jaden.
So just delete all that. Delete all that because it's already gonna know what you're meaning when you put on 4D projection or 4D space or
4D geometry projected to 3D.
Click on it. If it's a video or a picture, it'll probably look intriguing.
Oh, okay, yeah, that's exactly what I was talking about. Yeah, like that's Metatron's cube. Yeah, that's Metatron's cube.
Okay, so it's as if you're projecting the 4D platonic solids, interlocking, broken down to would make.
Yeah, it's basically so we see in 3 dimensions, right? And we exist in a fourth one. This would be the idea of like stepping back from that dimension, being able to see a 4th dimensional object from like a 5th dimension.
That makes sense. And what that would look like broken out. Yeah, the way you make multiple dimensions, because
I like this.
You literally like that's not literally accurate. You can't actually like represent a higher dimension, lower dimension.
Right.
You can't even represent a 2-dimensional.
Yeah, that's that's like literally not.
Yeah,
it's like this shadow.
But
that's
but in your mind, it's possible,
right.
And this is where it gets fun because you can actually train yourself to imagine what. Okay, like when you're trying to think of higher dimension, usually it's a person like you or myself who doesn't have a particular application for it that we're like dying to figure out how it works. But the idea of it even takes us to like this higher level, like you're just so intrigued or you're so like mesmerized, or it can be hypnotic sometimes, especially if you've
well, like God shapes.
Yeah. Or and you know it can be, especially because it's better to take these like symmetrical geometry and try to imagine them because they literally create way cool shit like this. I mean, just physically, like take the math of it, break it all down. That's what it would look like to have these edges and vertices like interlocking in that point in this 4-dimensional space. But that's the 3D representation. Couldn't actually 4D, but that is what it would look like if you were doing it. There's this book that was written years and years ago, back when people were still like way dope on that, and it's called Flatlander. It's a book about a 2D space, 2D characters. They got 2D, and he basically like is able to experience these snapshots.
That's crazy.
And so, and the reason the book was written was to kind of, because it's easier to conceptualize in your mind what that would look like. If you take a sphere, for example, 3D, but you live in a 2D world. When you bring the sphere to where you can see, you would see a cross section of that 3D sphere, which is essentially just taking one off the amount of clear now you're, which you also might purple, right? So same when you get a cube. But now when you get the cube, similar to what's happening here, if you rotate the cube on any axis or any combination of axes, you're going to get an odd shaped, like rhombus, rectangle, anything, right?
Right, so this would be a cube. So back away from that, you would have to be able to see a cube from all its,
which is this. And if you look at it, all the sides are actually and it's even cooler if you were to be able to see it move the way it moves in space too, because what happens is like, because that is actually a very isometric version, because each of the, like if you turn that in 3D space in the parts you're looking at are going to be mostly really sized, but in 4D space, what you're viewing as like the outside squares and rectangles that are making what you can as edges
Yeah.
those are much, much larger, and the only reason they're scaled like this is because you couldn't actually
So you could observe the shape in the first
exactly
place.
it has to be made like this because it represents the actual form it would take, but it's the only way to make that you build in 3D because the angle like in 4D the way you get another um when you work with it mathematically like physics and stuff,
Yeah.
you add an orthogonal plane, and the only way that we know of to make orthogonal, so when you have one plane, it's orthogonal, uh, has to have like a relative, but when you have two planes, orthogonal by making what you know XY graph.
Okay.
They're orthogonal
Yes.
because they're at 90 degrees.
Yeah.
And now when you base, you have another one that's also orthogonal because it is 90 degrees compared to X axis and compared to the Y axis.
Right. You need all three to get area. So.
But now,
Yeah.
But now, when you try to add a fourth plane, when you believe that 3D is like the thing, physically do it because there's nowhere, no angle to get in between any two of those anymore.
Yeah.
It would make 90 degrees. Cut X and Y in half, you're 5, you cut X and Z, or Z and Y,
Yeah.
the opposite of those, then you have 45 degrees. So the fourth dimension is now a dimension which could also be thought of as a direction, which is 90 degrees against each of those three. So that's like almost like in on itself or out on itself. That's why what I was saying, like those edges. If you can see this one, if you look over on the right hand side of the screen, you see how there's like that circle and it's like beveled edges.
Here, go to
Over here?
Right side
right,
of the screen.
Right side over here.
In the middle picture. Middle picture on the right hand side. That
Over
one.
here. This one?
That one. So see how
Yeah.
so like the far edges are connected to what is intended to look as something as right next to it. So it's connected by these thin rectangles, right?
Right.
But that direction is not a direction, and there's no way to actually represent it, or even a curve, unless the computer model is algorithmic, um, calibrated or to show an angle similar to what you're seeing.
Oh,
there.
so it's like a
This is an
it's like an
adjustment.
inside out angle.
Yes, totally.
Okay.
This
Cool.
is an adjustment to the angle, bringing it into the angle.
So it literally it went from this to like that, and you're seeing the flat surface of that.
Yes, exactly.
Okay.
Like because the angles don't exist. You're not like if you have 3D space, you're going like okay, I'm going up
Not there anymore, yeah.
2 degrees from the x-axis, then I'm going up 3 degrees from the y-axis and 14 degrees from the axis. So you're at like this. Now you can get into like polar coordinates and like arc tangents and stuff to figure out like where you're facing, where your directional vector is. But when you do the fourth dimension paper, you can get that directional vector, but you couldn't put it down as like a direction that you can observe in relation to the direction you know about.
Okay.
Even in your head, it's hard.
Right. I have an understanding of what you're talking about.
Yeah, like now that you
sure.
know that it's so much different than what you could know if only what you knew is what you could have.
Right.
Which kind of makes you think, what did people think about this? But
dude, they just sat there. They stared at a wall.
But here's the cool thing though. It's not actually real. It's
theoretical.
It's theoretical, and it's also beautifully the only thing that lines up to everything else. Like so that's why it's so well standard. It's held its ground, right? These ideas.
Got some feet, that's for sure.
Yeah.
Yeah, multiple people have been like, okay, I tried it, it makes sense.
Yeah, you literally can do this weird stuff on paper. There's actually a lot of physics.
Well, that's how you know
problems.
math problem's right if you reverse the math problem, right?
Yeah, and if you have to actually experience it and then it all comes out in the wash, it's like, yep, must be right. One of my favorite that I proved that so fun. I've still yet to do what I really would like to do to like prove everything to myself. But one of my favorite was, you guys know what a parabola is, right? Like
Yeah.
if you take a piss in the woods, like your pee's always gonna follow
Yeah.
the arc of a parabola.
Of a parabola. Yeah. It's just
every time.
yeah.
But
Parabola.
so now imagine you have a chain, whether it's a gold chain or a rope or a chain of like the can kind of you get out when you're 8th grade. Like they'd have like
Yeah.
a necklace.
Yeah. Okay. Yeah. I know what you're talking about.
Anyway,
those
so
yeah.
you grab it from two ends and you hang it.
Okay.
Right? You just let it hang. What's the shape it's making?
Fucking parabola.
You would think fucking so, right? Not.
Oh.
Not.
Is it because it's not perfect? Do I have to like?
No, it's because of some very strange effects unknown to the world until years after it was already known that it was a new shape. That it wasn't a parabola. It's called a quaternary.
Go ahead and look up.
Caterny. Quaternary.
Wait, CAT
ER
ERN.
or NARY.
NAO.
Quaternary.
NAO.
Quaternary. No. So
Nope.
maybe quaternary? Put math after it and it'll probably autocorrect to something. But anyway, the shape is made, even if you have like a chain, like an actual chain, where the chain links have like a length
Yes.
and
Okay.
each chain link's connected, you know, obviously like at each point, it's such a, you can never know where the point of contact is. Like maybe one chain's like this, maybe one chain's like this.
Okay, so
even from that, that's not what makes the quaternary. That's what's strange about it.
Okay.
Even with that, what happens is that it's based on like the weight distribution, and it almost like takes gravity into account in a way. But another cool thing about it is that the that arch in St. Louis is not a parabola.
Oh.
Upside down.
Okay, I see what you're saying. I think I kind of see what you're saying. The idea
Like
is that it
arch
cannot reach such a perfect state to be a parabola. The fact that it is made of matter, the distribution of the weight makes it a quaternary.
No, it was intended to be a quaternary.
Oh,
Because it could have been a parabola. Like it's
oh really? Okay, so then what's
a
the difference?
quaternary
Explain better.
It's a nap or two. Okay, like the reason your PE does a parabola when you piss in the woods or anything does, like it's because of the laws of gravity. If gravity were to exist, right, which is definitely
Crazy.
but it's only because like that's what everything does. If you throw an apple out of your car, gravity is going to follow the arc of a parabola.
Oh, okay.
And it's because, I mean, is according to Einstein, it's because of that. Basically, like adding one more dimension is squaring the not the moment, but what the fuck do you want to call it? It's trajectory, and it's relative to it.
Okay, so what would I have to do?
Because like you know what a parabola is, right?
Yeah, I know what a parabola
it's
is.
X squared, or like it's a function raised to the second power.
To the second power. Okay, yeah, I know what a parabola is. Okay, I'm sorry. Yeah, I see what you're. The actual equation.
Yeah, and it's because of the physical phenomena of this that are why we even see those things represented as what we can break down into a parabola, which is just the slang term for that shape.
Right, how a building falls.
But it also was used because they had figured it out back in like ancient Greek times. They had used it to try to make like a death ray.
That's dope.
Because it's also a shape that has the conditions where it's met that any like angle you go into it, like it'll come back to a certain point, focal point. Like so, if you have a fucking mirror that's shaped like a parabola.
Okay, so would you put that in the center of the parabola or like at the arc?
Well, if it's something like a flat parabola where it's like curved mirror, right?
Okay, now I see.
Like you have a mirror and you curve it along a cylinder, so it's just curved